Hello, my paper is Bayesian hybrid matrix factorization for data integration. What is matrix factorization? Just like how if you have a number, say 20, you can split it into two numbers, 10 and 2, which are factors, and if you multiply them, you get 20. The same way, you can split a matrix into two smaller matrices known as latent factors or latent matrices, such that if you multiply them back, you get the original matrix. The beauty of this method is that if you initially have a matrix with missing values, you can split it into latent matrices such that if you multiply them back, you get back a complete matrix with predicted values in the missing cells. An extension of this algorithm is matrix trifactorization, where you can split a matrix into three different matrices such that if you multiply them back, you get the original matrix. This is normally implemented when you're missing an entire row or column of data. Another extension is known as multiple matrix factorization. Here you have two different data sets, and if you can get a common latent matrix which is shared among both the data sets, and you multiply that with a separate latent matrix from one of the data sets, you get an integrated data set. So the evaluation data sets decided were the UCI breast cancer data set, UCI spam data set, and the UCI letters data set. And the evaluation metrics used was root mean square error. So as you can see, this method performs extremely well, especially on the breast cancer dataset and the spam dataset. Moving on to the implementation. So um, initially, the path provided is the path to the main directory, which contains the main.py file and the um, subclass file which has a refactored code. Um, then we create an object of that class. And next we provide the path to the input folder where all the data sets are present, and we also give the file name of the particular data set that we would like to run. This is given as input to our preprocess function, which reads this data set and readies it for imputation. This function finally performs the matrix factorization to impute the values and provides the evaluation metrics and results as well. We go through the number of iterations provided is uh, varied. It's up to the user. I've provided 1,000 iterations in this case, and it's shown to provide extremely accurate results. As you can see, as you go through the iterations, the RMSE value decreases as you go more and more. This algorithm, for this algorithm, we also provided the R square and Pearson's coefficient as extra evaluation metrics as well. So as you can see, after 1,000 iterations, the final RMSE value we get is around 0.46, which provides extremely accurate results for data imputation. Thank you.